So, welcome back. In this part, we're going to go through a few more Git commands, and we are going to be simulating another developer on the system. So, we've been working in the YouTube 3 folder. Let's go and build pretend we're a new developer on a new machine, working alongside this developer on this machine. And it doesn't have to be developers doing this, it could be designers working on a design. A version control system is helpful for anyone working in a system that needs to maintain a history, maybe some mutability in content. So let's see what folders I have in here so I don't get confused. Let's create our fourth folder, YouTube 4. So there's nothing in here. We are going to grab the repository from the remote, and we do that using clone. I'm working on my local file system right now, so it's going to be relative to my local folder structure. Git clone, and I want .git into, so I'm the key points are clone the URI, which in this path is a go back a directory and into YouTube 4 Git repository, and then clone it into .bing itself, the current directory that I'm in, which is YouTube 4. YouTube 4 origin. Can I even read origin 4? Just making up stuff. Okay. So that's cloned into here. Let's check that. There's our ATXT. Less ATXT. Yeah, there's a hello world text. So we've got two developers, developer A, developer B. So let's get some toing and froing going, which will simulate two people working on the code base. Reason being because in all, you know what it's like in version control systems, when you've got two people working on something, you go to push or commit your code into the repository, maybe an SVN or Mercurial or CVS, TeamCity, whatever you've been using, and then someone else has beat you to it and they've committed ahead of you, and you need to update your system to reflect their changes first. So that's the aim of the game for this exercise. So we've got the latest code, git tree. So let's work on this stuff. We're going to add some content to it. So atom ATXT hello world. So let's add a new feature. Save. Let's jump back in here. Git status. So change is not staged. Let's stage these by adding A. And let's commit him. Added a new feature. Great. So if we do a git status, you can see that we're still on master, and we are ahead of origin master, i.e. the remote server, by one commit because we've just added this new feature. So use git push to publish your local commits. And we should be able to see that by looking at the tree. So if we look at this, we've got two now in the stack. We've got the original, the origin master, which is the remote server. In both head and master are both pointers pointing at the same commit. and our local system, you can tell it's local by it not being prefixed with origin /. Both origin head and master are pointing to our new commit. So we're actually ahead of and on top of the remote. So if we do a push and push our contents to the remote, you should see the pointers on remote update. So git push origin master. So what do we have here? So we've gone, so you can see writing objects, some bytes, so data is being sent. We can see that these shards have changed. So our pointer has gone from master to master, but that really says ending in 395 has gone to ending in 789. So on remote, it's gone from 395 to 789. So master is now updated to being the same as our local. So let's look at the tree again. Yeah, so we've pushed our content upstream, and we've also moved the pointers of origin master and origin head to the latest version on the stack. So our feature is complete. That's now pushed onto the remote server. Let's jump back onto our developer A machine, git status. So when we do git status on our left window, it says you're up to date, you're cool. And we know that's not true, because the other developer is ahead of us. So going back to our previous video where we talked about git fetch, we can use git fetch to ping git on the remote server and find out what's changed. So you can see that something happened. Unpacking objects 100%. If we look at this visually in the tree, we can see that our local system, we don't have the prefix of origin, is behind the remote system. So we can do git fetch as much as we want. It's basically checking the system. Has anything changed? Has anything changed? Has anything changed? We can run it 1,000,000 times. Nothing's going to happen because nothing's changed. But if we do a pull, based off that new given information that we're behind, pull is going to update us so that we're in sync with remote. Now, when you think about it, or you think in your head, you think it's going to first download and then apply it. And apply it to your local system. However, in reality, the fetch actually does the downloading of all the stuff, but it does not apply it. And we don't have an indication of data downloaded in the fetch, but that's what it does. So fetch does the downloading, and pull, in fact, only really manipulates your pointer from, in this case, it's going to manipulate our pointer when we do a pull from pointing to here to here. And some indication of that may be the speed, right? If we had gigabytes of data that had changed, if we did a fetch, the fetch would take the long period of time, but the pull should be instantaneous because it's just updating a pointer. Anyway, we're going to do a pull because we want to get second developer's code. Pretty quick. There wasn't any indication of unpacking that we had in fetch. There was no unpacking of objects. It just fast forwarded, updating. So fast forward, when we look at our chars, so pull moves the pointer. So this is our char stack. And Yeah, you can see it fast forward basically was here in time. Now it just fast forwarded onto here. Great. So no biggies there. So let's now start working on something. So I typically wouldn't ever work on the master branch. I would always build features off on their own separate branches, because it gives you the ability to jump back onto the master. It gives you the ability to throw away a branch if it sucks. It allows you to pull in things between different branches. It works as a very good way of organizing a system. So from a heuristics point of view, you should really always be working with branches as often as possible. So how do we create a branch? So we've done a clone to our other developer. Branch. So the shortcut for this is git checkout -b, the name of our branch. So we're going to call this new feature. Let's just borrow this. So we could do git branch and create a branch. Then we could do a checkout to jump onto the branch. Or we can just compress this into one statement and use a checkout with a -b parameter to do both things at once. And if we check out, or if we see what status we're in right now, we're on the new feature branch. And if we do a tree, you can see that we have the original pointers that we were aware of before, and then we've got a new one called new feature, and he is pointing to the same point on the stack as master. So he's in sync. So let's go and do some work in here. New feature. So here, that was by the second developer. Let's go and add a. Okay, that's our small changes. Awesome. So I'm doing git commit -am just to say everything that's changed. The message is added a. Hit status. Git tree. So we are now ahead of the remote server. So we don't want to be pushing our new feature branch onto the remote server, because if we look at, let's scroll up, if we look at how the two systems are set up right now, there's your local repository, and then we've got the remote repository. And we have on our local, we have master branch with this is my little pretend tree structure with one branch coming off it called new feature. Move the other branch over there. And on our remote system, we just have master. And we don't care about pushing new feature onto the other repository because it's just a temporary branch on our local system. Most branches are. They're just for your eyes only, I guess. So for us to communicate these changes across the system, we need to pull new feature back up into master. So master has, because we came off master, we want to bring it back into master because master is going to be the commonality between these two systems. So if you do git branch, you can see what branch we're on. So we're on new feature. If we look at git tree, we can see that we're logically ahead and built on top of master. Like master's foundational, some sort of scaffolding for us to build this A feature on top. So what we need to do is we need to jump back onto master. In checkout, let's throw that into our list O interesting commands. So checkout really is a pointer mover. So in this world where we've got this head moving around, we can control that position by checking out. So we're back onto master, and the steps you'd want to do for merges. If you went from branch A to branch B, you'd make your changes in branch B, then you jump back onto branch A and merge in B's changes. So we've jumped back onto master and we're going to merge in the changes. Git merge, what branch was it? New feature. So based on our analogy of this being built on top of this, we know that everything that's in this commit is in this commit plus the changes. Or if we look at it from the other way, all of this is stored in this plus some changes, and all of this is stored in this plus some changes. So from a merging point of view, when we merge this new feature into master, Git can just see, oh, this is built on top of this. This must be a very easy merge. This fast forward is a good sign. It was a very easy merge for it to do. Git tree. So you can see that our new feature pointer is in sync with the master pointer. So if we do a git status, you can see that we're ahead. Our commonality is this master link between these two. We're ahead by 1. We're really now like master plus new feature. Whack all this. So we want to push that up. Git push. So we've now, if we tree that again, we can see that our origin is in sync with the new feature, which is in sync with master. Everything's in sync. And then remember, for this guy, we need to do a fetch, because the status will say that we're up to date, but if we do a fetch, you can see that we're actually behind. Okay. So then we'd do a pull and we'd grab this YouTube 4 would then have this folder over here. The second developer would then have the latest and greatest, which is YouTube 3, which would be A, right? He's missing A right now. So that is a very simple merge. We're merging one branch into another branch. We see the fast forward. Ooh, we'll save that for another tutorial. The interactive rebase. And that's it for this episode. I hope that cleared up some things. I hope you think about Git from different aspects. I hope that made sense.